All right, let's take a look at this question here that's involving forces and kinetic friction. And like I said, this is the kinds of questions that I get students who ask me all the time. If you have any questions, go ahead and send them to questions@bothellstemcoach.com. I'd be happy to take a look at them. But like I said, this is the kind of thing that I usually answer for a lot of my students whenever they have questions on problems. And so here's another example of someone who sent in a question. So the force F is exerted on a block and pushes the block against the ceiling. At the same time, accelerates the block to the right. Find the kinetic friction between the block and the ceiling. Okay, so what we would like to know, here is we want to start with a free body diagram. Actually, when they say the kinetic friction, we'll just say what the frictional force is in terms of like some of these things here. So let's take a look at our free body diagram. This is how we're always going to start. So we have gravity, mg, right? And then we always think about what's touching it. Well, we have this F that's touching it here, and it's pointing it up to the right. So it's going to be pushing it up and to the right like this at some angle theta. And I always like to annotate the angle theta on here just because we're going to have to decompose it. What else is so there's something touching it right here. What else is touching it is there's a surface right here. This surface can only push outward from the surface. It cannot pull, so the normal force is going to be downward because it has to be outward from the surface. That's the rule for the normal force. It cannot pull up towards the object into the wall or into the ceiling. It can only push away from it, so it's pushing downward perpendicular. Now, there is going to be kinetic friction because on a surface you might have a parallel force, which is friction. So the question is it to the right or is it to the left? Because it's accelerating to the right, and we'll assume it's sliding to the right. They didn't actually say which way it's moving, but let's assume that like it's actually moving to the right. Then the frictional force is going to be acting to the left. And I hope you guys notice that because the accelerating to the right doesn't necessarily mean it's moving to the right. It could be going left and slowing down, but we're going to assume, I think by intention, that they mean for this block to be actually sliding to the right, in which case the kinetic friction is going to be parallel to that surface and opposite the direction of that surface. So we've completed the free body diagram here. So now the next step is to decompose, or to identify the acceleration. The acceleration is to the right with A, and we are going to decompose any forces into the x and y directions here. So we're going to make this one. So this one is up and to the right, so we're going to make it upward and rightward. You want to follow those arrows, just like, this is going up and to the right, and this arrow's up and to the right. So this is F cosine theta, because it's the adjacent side. We're just making a right triangle here. This is F sine theta. The arrow directions do matter. Now we need to assign positive and negative directions. We'll say right is positive, we'll say up is positive. I'd make right positive just because the acceleration is to the right. So I always like to if I know there's an acceleration in their direction, I typically make that the positive direction. You are not required to, but I find it's a lot simpler when you do it that way. Okay, so in the x directions, we're going to do F net equals ma. What are all the forces in the horizontal direction? Well, we have F sine theta pointing to the right, so it is positive. We have force of friction pointing to the left, so it is negative. And that equals the mass of the object times its acceleration. Okay, and in the y direction, if we do F net equals ma, we have an upward, all the upward forces are positive, so F cosine theta is pointing up, so it's positive. And then Fn and mg are pointing down, so they are negative. Now in this case, the vertical acceleration is 0 because it's not going up or down, it's only accelerating to the right. So it's m times 0 in this case because there's no vertical acceleration. So you have F cosine theta minus Fn minus mg is equal to 0. So those are our steps for Newton's second law. So now the question is how are we going to find the kinetic friction between them? And it kind of depends on what we're given in a problem. Are we given the theta? Are we given the acceleration? So I'm going to give a couple of answers just because this question is not super well formed in that, but at least the process is important. One, the easiest way is you could solve for the frictional force here and just equal to F sine theta minus ma. Okay, that's one way we could do that. Okay, and then if you knew F, you knew theta, you knew the mass, you knew the acceleration, then you'd be good. Let's assume we are given all that information. But they also note mu here. Force of friction for kinetic friction is also equal to mu times Fn. So you could say solve for Fn on this case. It would be F cosine theta minus mg. And then plug that into there. It would be mu times F cosine theta minus mg. Okay? I'm going to guess what they actually wanted you to do was solve for the coefficient of kinetic friction. Let's say you wanted to solve for that. Then you could say like, oh, well, then I know these two are equal. So then I could say mu times F cosine theta minus mg would equal F sine theta minus ma. And then you could just solve for mu. Again, it's not entirely clear what exactly they want you to solve for and what variables they're allowed to give in you. So I would say any of these, depending on what they were asking you, would be valid answers. This is solving for the force of friction, and this is solving for the coefficient of kinetic friction. Just because, yeah, I mean, it could have been any of those. It just wasn't super clear on what was being asked. But the big part is to understand, make sure how you do the free body diagram, you set things up, F net equals ma. That process is the main thing that you want to learn when you're doing these kinds of force problems.